bracket x to the power 4 plus x squared. Okay, and then what is going to happen is that now, because this has been assumed that it is u, then we can put it back into the above equation. Then it's going to be y equals to u, and then open bracket to the power 5. Okay, so now what this means is that we can actually sort of like differentiate, okay, this one, and then once we differentiate that one, and also we differentiate this one, and then just put it back. So it's sort of like interconnected. So what you can do now, you're saying that y equals to x to the power 4 plus x to the power 2 to the power 5, and we know that you have said that u equals to x to the power 4 plus 2, plus x to the power 2, okay? And then what you're going to do is we take the derivatives of, not that one, we take the derivative, differentiate this one, and since now we know that u is this now, so then we can substitute saying y equals to u in bracket to the power 5. So we also take the derivative of this one. So now we know we're going to say du over, now differentiate this one with respect to x, because that's what is changing. That is the independent thing. So du over dx just going to be, now you go back to this standard principle. So this is going to multiply with the coefficient there is going to be 4x and minus 1 if the power. So we have to the power 3 plus, now remember that this is 2, that is x to the power 2. So I just want you to know that. Go back here, so differentiating this term is just going to be 2x. Okay, now so we have taken the derivative of that, and then also we define, we find the derivative of this y equals to, because y is defined as a function of u to the power 5, and this is going to be now dy over that was du. Okay, so dy, of course, dy over du. Okay, and this is now going to be this is just 5, so this power 5 multiplied by the coefficient there is going to be 5u to the power 4. Okay, so now these are derivatives that we have now. So what's going to happen is that I can now just sort of like embed these two. So now the derivative of dy over dx is just simply the idea that the idea of saying that just put them together, okay? Put them together. So we're going to say du over dx, okay, multiplied by dy over du. Okay, so now we understand that. Okay, so now after we do that, then we are going to have du dx. So is this one, so it's just 4x to the power 3, 4x to the power 3, okay, plus 2x, and then since I'm multiplying, it's going to be dot 5u to the power 4. Now remember that the u was something that we had to just relate, okay? So u, we know that it was given as x to the power 4 plus x squared, okay? So now we can actually now factor this one into that, or rather just replace this what is u, because we don't want to have three, sort of like variables, or rather two variables on the right hand side. Okay, so what you're doing now is simply saying now, okay, simply saying that dy over dx will now be equal to 4x to the power 3 plus 2x, okay? Or if you want, because multiplication is commutative, so what you can do is you can sort of say 5 in bracket, and then x to the power 4, x to the power 4 plus x to the power 2, okay, and then the other part, x to the power this plus 2x, then you do that. So this gives us the final derivative. So this is basically some of the fundamentals of what differentiation is about, and this is what we call the chain. So it's a chain rule, okay? It's a chain rule. So you have to make sure that you understand the basic principle of calculus before we go to integration, okay? So thank you so much for watching. Remember to subscribe, like, and share this video.